implies another important, very important concept, which is congruency. So first of all, I'm wondering, can someone tell me, and pop it in the chat if you know, what does it mean when shapes are congruent? What does it mean? Pop it in the chat. Tell us, what does congruency mean? iPhone K, tell us what your name is so that we can change it from iPhone K. We don't keep calling you iPhone K. Miss Kaka, will you change it, please? iPhone K to Koki, it seems. Nice, everyone. That's exactly what it means. It means that they are exactly the same. Now I'm going to ask you to further describe what does exactly the same mean? In what aspect are they exactly the same? Are they the same shape? Are they the same size? Do they have the same angles, the same area? What is exactly the same? Shape and size. Some say shape and size. Shape, size, angles. That's right. In every way, they are the same. They are more identical than identical twins. Because you know, identical twins vary a little bit. They're actually not identical. Identical twins are actually do have like some. My mom and her sister are actually identical twins, and when I look at them, I can see, oh, there's like a slight difference between the two of them. It takes a while, but if you just look at them at first, they look exactly the same. But then when you look closer, you see, oh, there's some variation in the way they look. So when we are talking about congruency, the sides, the angles, the shape, and the area, all those aspects of the two shapes, well, can be more than two shapes, are the same. Okay, yeah. So Lashandra knows.
I was about to say, Miss Marlies, you're going to have to help me on how to figure out the difference. We have 6 sets of twins at my school, and I can't tell a single difference between them. I call them all by their surname now. It's Mr. whoever, because I know they share a surname because I don't remember their names.
You know that they probably use it to their advantage, that they look so similar. They probably pitch for each other's tastes and stuff like that. So just find one distinguishing feature, be it a mole, an ear or an eye or something that's different. The way they wear their socks, there is something that's different, I promise you. With my mom and my aunt, it's their voices, actually. They sound so similar, but when you listen carefully, you actually pick up who's who without looking at them. Okay, so we've got these 4 cases of congruency that you learned in grade 9. So if we are working with triangles, so congruency only applies or these 4 cases of congruency only applies to triangles. What we are not going to look at in this course in particular is similarity. Now, similarity shouldn't be confused with congruency. Can anyone tell me, what does it mean when 2 shapes are similar? So we've established congruency is exactly the same. And similarity, what does that mean? Pop it in the chat if you know. What is the same if shapes are similar? Nice, Koki, that's right. Same shape, but different sizes. Different size angles, different size area, etc. But they are in proportion. But yeah, like I said, for now, we're just going to leave similarity there. I thought we'd just briefly look at it so that you know there is similarity and congruency, congruency being exactly the same. So congruency, we use the sign with the 3 stripes, like Adidas, the 3 stripes, for congruency. And when we prove congruency, there can be these 4 cases for congruency. So 3 sides must be the same. Now, what's important with both congruency and similarity is that the sides and the angles that are equal must be corresponding. So corresponding means they must be in the same position. So if we look at these 2 triangles, for our first case of congruency, for side, 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 this side, AB, is in the same position as DE. So it is important that when you do your congruency, that everything that's equal must also be corresponding. So if it's like this, so AC and DF, those sides are corresponding, and then BC and EF are equal, and they're also corresponding. And then, of course, these lines, these little markers on the sides, they mean that they are corresponding. Not corresponding, that they are equal. And when we have a dot for an angle, it means that those 2 angles have the same magnitude, they're the same size. Okay, so that's side, side, side. That's the first case for congruency. Then the next one is side, angle, side. So again, if we have a side and a side that's equal, and then another side that's equal, and then the angle between them. So make sure that it is always side, angle, side, meaning it's 2 sides and the angle between them. That will make a case for congruency. Now, just remember, these are the only cases for congruency that exist. So you can't make up your own. These are the ones that I know. I've seen grade 10s make up congruency cases. Same as Coco, have you? I mean, I find it interesting because
I'll grade 9. The grade 9, right? They feel the same. So.
No, it's not about what they feel like or look like. It's what you can prove. Okay. I always say that geometry is a bit like solving murder mysteries, because it's not what your intuition tells you, or what it looks like, or what it looks like on the surface. It's all about what you can prove. And if you want to prove congruency, you need to prove one of these 4 cases for congruency. Okay, so next one is side, angle, angle, or angle, angle, side is also fine, as long as it's 2 sides and 2 angles and 1 side. And then condition 4 is when we are dealing with right angle triangles. And be careful, it's not always that you're going to do RHS in all right angled triangles. It has to be very specific. The right angle, the hypotenuse sides, and another side. And again, they must be all in corresponding positions. Okay, can I see by way of a thumbs up, how are we doing with this? Is it coming back to you from grade 9? Put a thumbs up in the chat if you're happy with these 4 cases of congruency and you are remembering them. Nicolita, one day I hope you find we can see your emojis. Okay, so the last one works in right angle triangles. So we have the right angle, the hypotenuse side. Remember, in a right angle triangle, the hypotenuse side is always across from the right angle, and then another side. So that's what RHS stands for. Okay. Remember, you're welcome to take screenshots of these notes and pictures if you want to use it for studying purposes. or for keeping a record of your lesson. Otherwise, you are welcome to be writing it down in your Watobe book that I believe you all have. But yeah, make notes as we go along, especially if you feel like you've forgotten all your grade 9 congruency. Okay, so let's go on. There's one more question. I just want to ask, if what does S mean in condition 3? Side. S means side. A means angle. R means right angle. H means hypotenuse. And S. So those are all abbreviations. That's what it basically means. So SSS is side, side, side. SAS is side, angle, side. SAA is side, angle, angle. And RHS is right angle, hypotenuse, side. Okay, let's see if we can recognize some congruent triangles. So here I've got 6 examples. I want you to now look at each example and then state whether the pairs of triangles are congruent or not. You can ignore this. I don't want you to do that. But what I do want you to do is say what is the case of congruency if they are congruent. Okay, so let's have a look at the first one. You can put your answer in the chat. Say first if they are congruent and then state the case of congruency. So it's either side, 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 angle, angle, side, or right angle, hypotenuse, side. Yeah, guys, listen carefully to the instruction. Say whether they're congruent and then give the case of congruency. And when you give the case of congruency, it can only be one of those 4. Don't make up your own case of congruency like we joked earlier. It's actually quite serious. You can only do that. One of those 4 cases, those are your only options. So if you're not writing that down, it means you're making something up. Okay, so if we say that they are congruent because of side, 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 it means that 3 sides must be equal. But what have we got here? We've got a side, and they are in corresponding position. We have a side, and they are in corresponding position. And then we have an angle. I don't see 3 sides here, okay? So this can only be 2 sides and the included angle. Side, angle, side. Okay, good stuff. If you didn't get that one right, let's give this one another go. Pop in the chat if they are congruent and what the case of congruency is. Number 2. Again, if you are putting down side, angle, side, it means that you have 2 sides and an angle that's equal. Work with what we've got here. Yes, they are congruent. I agree. So we've got side and side and side and side, and then they share a side. This AC is what we call a common side. AC is common. That gives us 3 sides. There are no angles indicated that are equal at this stage. So we can't just make stuff up. We can only work with what's there. So we've got 3 sides. They are congruent, 3 sides. Okay, so if you said side, angle, side, be careful because there aren't any angles indicated at this stage that are equal. Okay, let's go to number 3. Same story. Okay, so people are saying that it is because of right angle hypotenuse side. I would agree. Yes, they are congruent. They are congruent. Let's have a look. We are saying it's RHS. Let's see if that works. Right angle and right angle. So look at the two triangles and find the things that are equal. There's a right angle and a right angle. Do we have the hypotenuse side? Yes, over here and over here. AE is equal to BC. And then do we have another side? And they must be corresponding. So it's DC and ED. So they are corresponding because it's the longer side of the two remaining sides that are equal. So yes, they are congruent because of RHS. Okay, let's go to 4. State whether they're congruent or not. And let's be careful. Yes, Letabu. Letabu, you can unmute and ask your question. Okay, not sure what happened to Letabu. Okay, so there's disagreement in the chat about whether these are congruent or not. If you are saying it is, okay, that's fine, Letabu. If you are saying they are not congruent, you would be correct. They are not congruent. Okay, so we have angle M and angle M. They are in the corresponding position. They are in the same place in the two triangles. Then we've got angle N and angle N. And that's fine, angle so far. But now look at the side, AC and EF. Those sides are not in the corresponding position. So we cannot get the side. So they are not congruent. Yes, Ayabonganene, that is exactly what question 4 is about. The sides are equal, but they are in different positions, and then the congruency doesn't work. Okay, so not congruent for question 4. Yes, Leletu.
So ma'am, are you saying that if they're not on the same sides, that means that they're not congruent?
That's right, if they're not in the corresponding position.
Okay, thank you, ma'am.
Okay. So if we look again at side AC in triangle ABC, side AC is across from angle M. And in the other triangle, EF, which is equal to AC, is across from angle N. So it's not in the right position. We need it to be over here for it to be congruent. Okay, let's go on to the next one. Number 5. Are they congruent and what's the case of congruency? Don't just guess, guys. If you're saying not congruent, you need to be sure why. If you are saying they're congruent, then you also need to be sure why. And if you're saying sides are not the same, be careful as well, because we need to get our words right. Yes, use the word corresponding. That is the right word to use in this case. Okay, so let's look again. So A and D, yeah, they are. So we've got the right angle. We've got the hypotenuse side, that is across from the right angle, but our side AB and our side FD are not in the corresponding position. So our side doesn't work. Our third part of the congruency doesn't work. So therefore, not congruent. Okay, and the last one, let's do 6. And also, guys, be careful. If you're saying not congruent, then you can't use one of the cases of congruency, okay? Because then it doesn't work. So if it's not congruent, you can't say this is the reason for congruency. The reason for congruency only works if you say that they are congruent. Okay, and we have a similar story here, not congruent, because let's go through that process again. We've got angle X and angle X in the same position, but do we notice that the two sides are swapped? So for this to have been congruent, we needed AC to be equal to DF and BC to be equal to EF. Okay, so not congruent also doesn't work. All right. And also, actually, it's two sides. Oh, that's the other reason why this one doesn't work. Because our reason for congruency says side angle side. So this angle X is in the wrong position. It needed to have been here for us to use side angle side. Okay, so the angle is not in the right position. Okay, now let's go on to actually writing some congruency proofs, which is important for actually what we are going to be doing in the next few lessons with quadrilaterals. So the reason we are going over congruency in quite a bit of detail is because you need your congruency knowledge for what we are going to do with quadrilaterals. Okay, so I'm going to do the first one for you. It is pretty much halfway done already. So we're just going to kind of warm up and then we're going to head towards writing our own proofs. But here we're just going to start by with a little bit of help. So the first statement, the first thing you need to do is always read carefully what it says, because sometimes what is written is not always present on your sketch. So get into the habit of doing that, of reading what it says and making sure that the information that's in the words are also there on your sketch. So it says in ABCD, AB is equal to BC. Okay, yeah, that's shown over here. And AD is equal to CD. And get a highlighter as you do this so that you can highlight the important bits and the things that are equal. Prove that ABD is congruent to triangle ABD is congruent to triangle CBD. So you always start off and you write this part here. Which triangles are you working in? And the reason you do this, no, it's not worth a mark. And I actually hate it when people ask me that question, because not everything you do in maths is for marks, but it is for your thinking and for having a good layout for your answer. So in triangle ABD and triangle CBD, you write that down because there could be many triangles in your sketch. So you have to say which ones you're working in. So we're going to start. AB is equal to BC. And then we have to give a reason. And the reason here is that it's given. We are told that up front. And then AD is equal to CD. That is also given. Now, what can we say about BD? BD is what? What is that word we need to fill in there? Common. Well done, Millie. That was quick. Common. So therefore, triangle ABD is congruent to triangle CBD. And which case of congruency are we using here? Which case of congruency did we do here? There's only 4. So we had a side and a side, another side and a side, and another side. So our reason here is side, side, side. Yes, Nokotula. Yes,
I'm
Nokotula.
asking why, for question number 3, now, why is BD common?
Do you see that BD is a shared side between both triangles? Do you see that?
Yes.
That's why we say it is common. It's a side in both of the triangles.
Oh,
So the
common.
word we use for it is common. No, we don't use shared or anything else. We just say that it's a common side. Okay? Great. Right, now the next one, we're going to go a bit faster. So in the chat, I want you to pop answers into the chat. Let me know. AB is equal to which side? Pop it in the chat. AB is equal to ED. And what is our reason? We're going to say it's given. That's right. It is given because it is shown on your sketch. And then BC is equal to which one? BC is equal to CD. And the reason there, also given. And then angle B is equal to which angle? Angle D. Thanks, Ria and Sakiwo. And our reason there is also given. Okay, so this is pretty easy because everything's given. You don't have to really think about it too much. And ABC is congruent to triangle EDC. And the reason, what is our case of congruency? Okay, if you did not say side, angle, side, I want you to write next to each statement what it is that's equal. Here we have sides that are equal, a side that's equal, and an angle that's equal. Is the angle between the two equal sides? Yes, it is. So it is side, angle, side. Right, the next one, I'm going to be quiet and I am going to let you do this for 2 minutes and then we'll check back in with answers. So work on your own now for 2 minutes. Don't put anything in the chat. Just work for 2 minutes. Okay, let's start checking. Don't put anything in the chat. You can just listen. Sakile, just hold. You can hold your answers for now. GF is equal to FI. That is given. H1 is equal to angle H2. That's given. And then FH is common. Guys, don't put anything in the chat. It's fine. You don't have to put your answers in the chat. It's a bit too much to just type out the whole time. So just follow along and make ticks if you got it right. And now we're going to say triangle if GH is congruent to triangle FIH. And our reason for congruency is right angle, hypotenuse side. If you got that right, put a thumbs up in the chat. Okay, our class is about 94 strong, so I want to see a whole lot more thumbs up or thumbs down. If you didn't get it right, that's fine too. Put a thumbs down. Make sure that you make a correction and that you know where you went wrong. Yeah, it's important to see your mistake. And Paul, make sure that you know where your mistake is. And if you're not sure, you must pop a question over to Miss Coco. She can also help you. Wami, I don't know why the crying face if you got it right. Okay. Now, in the next round, we are going to write our own congruency proofs. Okay, I'm going to do the first one with you. And then I think we have time for one more. Okay, so listen carefully. So we are going to first name our own triangles. Well, they're actually named already. So in triangle ABO and triangle DCO, we now need to prove that these two triangles are congruent. So I'm going to start with just looking at my sketch and seeing what I've got. Okay, I've got the two sides that are equal. Awesome. I've got these parallel lines. So that's really helpful because parallel lines give you angles that are equal. So if I do alternate angles, then I can say this angle A is equal to the angle D, and this angle B is equal to this angle here. And if I do it that way, then I've got side, angle, angle. Okay, so let's write that down. The first thing I'm going to say is that AB is equal to CD because it is given. Then we're going to say the next statement is that angle BAD is equal to angle CDA, and that's because of alternate angles, and I must name my parallel lines AB parallel to CD. And then the last statement is about this angle B and the angle C that's equal. So ABC is equal to DCB. And those are also alternate angles, AB parallel to CD. O1 and O2, yes, they are vertically opposite, but they're not going to give us something that we can use for congruency. So therefore, triangle ABO is congruent to triangle DCO. So what have I got? I've got a side and an angle and an angle. So my case for congruency is angle, angle, side. Okay. Now
Ma'am,
it's
I
going to
have
be
a couple of students asking if you couldn't possibly use O. And I think we can if we look at O as vertically opposite angles. So O1 could be equal to O2 because those two
yes.
are vertically opposite. And that would also be angle, angle, side in that case as well.
Yes, you can do that. Okay, right, guys, I want you to give question 2 a go. I'm going to let you work on your own for about 3 minutes. Write out your congruency proof. First, find the things that are equal and which case of congruency it is, and then you write out your congruency proof. Okay, we got about 2 or 3 minutes to do that. I'm going to leave you on your own, and we'll check back in a few minutes. Eunice, just work on your own. Just write down your congruency proof there where you are in your own book or exam pad. And in about 2 minutes, we're going to go through it, and then you can mark your work. Okay, so our time is up. So let's see. I'm going to go first with angle A1 is equal to angle C2. And the reason for that is because of these parallel lines. So it's alternate angles. And you must name your parallel lines AB parallel to CD. Then we can say that angle C1 is equal to angle A2 because of the alternate angles. So now already we've got two angles. So you should by now realize that we are heading towards doing angle, angle, side again. And since we have angle, and you know you need a side, where is that side going to come from? You can go AC is common. AC is common, and therefore the two triangles are congruent because of angle, side. Okay, someone is saying they did it differently. Just let us know in the chat what you did, then we can go through it. But that is all we have time for this evening. Ms. Coca, I think it's time for you to post the quiz link. If you did do it differently, you can still tell me in the chat what you did. But in the meantime, Ms. Coco is going to post the link in the chat. Okay, there you go. If you did side, 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 I'd love to know how you did it. Let us know. Maybe someone wants to put their hand up and tell us how they came to side, side, side. Okay, some of you realized that it was a quadrilateral or a parallelogram. Bye, Nati. Okay, Renilwe, you can unmute. Let's hear what you have to say.
Okay, ma'am. So like I said that AB is equals to DE and it's given. And then I said AD is equals to BE and then I said given. Then I said A is equals to C and I said common. That's how I said side, side, side.
Okay, so AB is not equal to DC because it is given. The only reason why AB would be equal to DC is because ABCD is in fact a parallelogram. Okay, so it's important that you use the right reasons. So if some of you use the fact that ABCD is a parallelogram, you would have needed to first say that it's a parallelogram. What is the reason for it being a parallelogram? Both pairs of opposite sides are parallel, and then you can use AB equal to DC and BC equal to AD. But if you did it that way, it's perfect, as long as you use the right reason.
Yeah, ma'am, can I just add to that? Unless they explicitly tell you that it is a parallelogram, you can't then assume that the properties of a parallelogram.
No, it's sufficient to have the opposite sides parallel, both pairs of opposite sides parallel.
Will
So
that
it
then
is
make
fine.
it equal?
Yeah,
Will
they
that then
don't
make
have
it
to.
equal?
Yeah, they don't have to say that it's a parallelogram in the question. The fact that both pairs of opposite sides are parallel, that makes it a parallelogram.
Oh, I see. Okay. I think Tuli is asking to her hand up. So, but she's done it in the chat. I need to find her. Tuli, can you unmute?
Hi, ma'am. Just wanted to ask, how is it angle side?
Because of the alternate angles, and then the side, that's common.
Oh, okay. Okay, thank you, ma'am.
Okay. A equal to C, B equal to D, fine, because of properties of a parallelogram. I'm going to write down this parallelogram part quickly, because I'm worried that people are making up reasons. So first you have to say AB, CD is a parallelogram. And your reason is both pairs of opposite sides parallel. Then you can say AB, this can be your first reason, AB equal to DC. And you never use properties of a parallelogram as a reason. You have to, which property? Because the parallelograms have lots of properties. So you have to say that it's opposite sides of a parallelogram. And then you say BC is equal to AD. Again, opposite sides of a parallelogram. And then you do AC is common. AC is common. And then ADC is congruent to triangle CBA, side, side, side. Okay, but your proof must look exactly like that for it to earn marks. Okay, guys, we have 1 more minute. Who has hands up? Ashley?
Ma'am, I would just like to know if for the ADC, is it congruent to CBA?
Yeah.
Okay.
Yes.